December 7th, 1941. 1847 hours, Berlin. The cigar smoke hung thick in the Reich Ministry conference room as Oberingenieur Wilhelm Schuler spread the intelligence reports across the mahogany table. The numbers made him smile. American merchant ship production, 1.1 million tons per year. German U-boat kill rate, 6.2 million tons annually. The mathematics was elegant, inevitable, beautiful. "Gentlemen," Schuler said, adjusting his wire-rimmed glasses, "the Americans have declared war on a force they cannot comprehend." He was 52 years old, educated at Technical University of Berlin, 30 years designing ships in Hamburg's prestigious yards. He had personally overseen the construction of the Bismarck, a vessel that took 3 years and 50,000 man-hours of skilled labor. He knew ships. He knew production. He knew what was possible. "Their shipyards are antiquated," he continued, tapping the reconnaissance photographs. "Look at these facilities. Bethlehem Steel, Newport News, they use methods from the Great War. Riveting, hand-fitted joints. Each vessel requires 14 to 18 months from keel to launch. They have perhaps 20 yards capable of building ocean-going cargo ships." Admiral Donitz leaned forward. "And if they expand production?" Schuller's laugh was genuine. Not mocking, just certain. "Herr Admiral, building ships is not like assembling automobiles. It requires craftsmen, master welders, naval architects. The Americans would need to train 100,000 specialized workers. This takes years. They simply don't have the expertise or infrastructure." He pointed to another document. "Their Liberty ship design? We've obtained the specifications. A simple cargo vessel, 10,000 tons, single screw, outdated triple-expansion steam engine from 1879. Even this rudimentary design, built in their antiquated yards, will take them 200 to 240 days per vessel." The room nodded. The logic was unassailable. "By our calculations," Schuler concluded, "even if they somehow triple their production, an impossible scenario, they cannot replace tonnage faster than our U-boats can sink it. The Atlantic is ours. Britain will starve. The war is mathematics now, and mathematics doesn't lie." What Schuler didn't know was that 5,000 miles away, in a dusty Oakland, California shipyard, a 48-year-old construction magnate named Henry Kaiser was about to make every assumption in that Berlin conference room catastrophically wrong. What none of them knew was that in 18 months, the Americans would be launching a complete Liberty ship every 24 hours. What they couldn't imagine was that a nation with no maritime tradition would produce more ships in 4 years than the entire world had built in the previous century. The arrogance wasn't unfounded. The Germans were right about everything they knew. They just had no idea what they didn't know. September 1940. Richmond, California. 94 degrees Fahrenheit in the yard. The smell of dried grass and bay salt. Henry Kaiser stood in an empty field staring at San Francisco Bay, and everyone who knew anything about ships thought he'd lost his mind. He'd built the Hoover Dam, the Bonneville Dam, the Grand Coulee Dam. He'd poured more concrete than any human in history. He'd never built a boat, not a rowboat, not a raft, nothing that floated. "You're a dirt man, Henry," said engineer Clay Bedford, squinting against the sun. "Ships are different." Kaiser was short, 5, 8, with round glasses and a salesman's grin that never quite faded. He'd dropped out of school at 13, worked as a photo supply salesman, made his fortune by figuring out how to pour concrete faster than anyone thought possible. His secret wasn't genius. It was ignorance that freed him from conventional limitations. "How long does it take to build a cargo ship?" Kaiser asked. "In a good yard, with experienced crews, 300 days, give or take." "Why so long?" Bedford blinked. "Because that's how long it takes. You lay the keel, frame the hull, rivet the plates, install the machinery, fit the interior. There's a sequence, a methodology. It's been this way for decades." Kaiser lit a cigar. "What if we don't know the methodology?" "Then you'd build it wrong. Or differently." The Maritime Commission thought Kaiser was a joke. When he'd bid on Navy contracts, the established shipyards, Newport News, Bath Iron Works, New York Shipbuilding, had laughed, literally laughed. One executive said to his face, "Kaiser couldn't build a ship if the plans were made of Legos." They weren't entirely wrong. Kaiser's first test vessel, built at his emergency Richmond yard in early 1941, had problems. The hull leaked. The electrical system caught fire twice. The steering mechanism jammed. It was, by every traditional metric, an embarrassment. But it had been completed in 169 days. The experts pointed out every flaw. They missed the only number that mattered: 169. Kaiser's advantage wasn't knowledge. It was the absence of it. He approached ships the way he approached dams, as big problems to be solved with American industrial violence. Brute force. Mass production. Standardization. The kind of thinking that made European craftsmen physically ill. The British Admiralty sent inspectors. Bedford told him after the test ship's maiden voyage. They were horrified. Said the welds were crude. The fittings were commercial grade, not maritime spec. The whole vessel was beneath naval standards. Did it float? Well, yes. Did it carry cargo? Technically. Then we're building more. What Kaiser understood, what the Germans in their elegant Berlin conference room couldn't fathom, was that adequate ships in massive quantity would beat perfect ships in small numbers. Always, every time, without exception. The Liberty ship design he'd been handed by the Maritime Commission was based on a 1930s British tramp steamer. It was deliberately simple, deliberately outdated. 5 holds, 2,500 horsepower engine, top speed of 11 knots, slower than most U-boats on the surface. It was designed to be built by inexperienced workers using basic techniques. Kaiser looked at the plans and saw something no one else did. A product. Not a ship, a product. In his mind, a Liberty ship wasn't fundamentally different from a concrete culvert or a highway bridge. It was an assembly problem, a logistics problem, a problem of moving materials and labor efficiently through a production system. "We need to hire 90,000 workers," Kaiser told his management team in October 1941. "Where? There aren't 90,000 shipbuilders in the entire country." Kaiser widened. "Then we don't hire shipbuilders." This is where the German calculations fell apart. They assumed American shipyards would need trained maritime craftsmen. Kaiser hired farmers, housewives, teenagers, retirees, anyone who could hold a welding torch or swing a rivet gun. Women who'd been secretaries became welders. Men who'd been grocery clerks became fitters. The average age in Kaiser's yards was 24. 60% had never seen the ocean before their first day of work. He built housing developments for his workers, cafeterias that served 30,000 meals a day, on-site childcare, medical clinics. He paid well, union wages plus bonuses for speed. And he trained them not through lengthy apprenticeships, but through targeted, specific instruction. This is how you weld this particular joint. This is how you install this specific valve. You don't need to understand the whole ship. You need to master your one task. The traditionalists called it degrading. Kaiser called it scaling. November 1941. Pearl Harbor was still weeks away. Kaiser's Richmond Yard No. 1 launched its first production, Liberty ship, the SS Ocean Vanguard. Construction time, 150 days. The Maritime Commission was impressed, but skeptical. Could he repeat it? January 1942. The SS Ocean Ranger, 126 days. February. The SS Ocean Messenger, 105 days. "It's a fluke," said the executives at Newport News Shipbuilding. "He's cutting corners. Those vessels won't last 6 months in the Atlantic." They were half right. Kaiser was absolutely cutting corners. He just understood which corners could be cut and which couldn't. A Liberty ship didn't need to last 30 years. It needed to last 1 round trip to Britain, maybe 2. If it survived long enough to deliver 10,000 tons of cargo once, it had justified its existence. This was manufacturing thinking applied to maritime construction. It was heresy to traditional shipbuilders. It was also the only thing that could win the war. March 1942. The SS Ocean Venture, 89 days. The SS Ocean Victory, 77 days. Kaiser's yards were learning, evolving. Every ship revealed inefficiencies in the process. Every inefficiency got eliminated. Workers developed shortcuts. Installation sequences were rearranged. Prefabrication techniques were refined. The Germans, monitoring American production through intelligence networks, noticed the increasing numbers. But they still weren't worried. Volume was one thing. Quality was another. And speed, they assumed, came at the cost of durability. The U-boats would tear through these crude American vessels like wolves through sheep. What they couldn't see from their intelligence reports was what was happening inside Kaiser's yards, the culture, the competition, the relentless drive for improvement. Richmond Yard. 2 built a hull in 6 days, Bedford reported one morning. Yard 1's crew is furious. They want to beat it. Kaiser leaned back. Let them compete. That's not how shipbuilding works. It's how this shipbuilding works. By summer 1942, Kaiser had 6 yards operating in Richmond and Portland. Each yard had multiple ways, launching slips where ships were built simultaneously. The yards competed against each other. The ways competed within yards. Crews competed within ways. The entire system was engineered for speed. A welder named Ava Calloway, formerly a housewife from Bakersfield, could join 2 steel plates in 11 minutes, faster than master craftsmen with 20 years' experience. She didn't do it better. She just did it faster. And for Liberty ships, faster was better. The rhythm of Kaiser's yards became mechanical, hypnotic, violent in its efficiency. Day 1, lay the keel. Day 2, 3, erect the prefabricated hull sections. Day 4, 5, install the engine. Day 6, 15, fit the superstructure, cargo holds, piping, electrical. Day 16, 30, paint, test, provision. Launch. 1 month, keel to water. Impossible by every traditional standard. And yet, what Wilhelm Schuler didn't understand, couldn't understand, was that American industry didn't play by European rules. The Americans had spent 50 years perfecting mass production. Ford's assembly lines, Sloan's logistics systems, Taylor's time studies. They'd industrialized everything from bread to bicycles. Why not ships? The British are complaining again, Bedford said in August 1942. They say our welding quality is inconsistent. Some seams are showing cracks." Kaiser nodded. "How many ships have we delivered?" 73. "How many have sunk due to structural failure?" Bedford hesitated. "None." "Then improve the welding, but don't slow down." This was the American philosophy in its purest form. Good enough, fast enough, cheap enough, and in overwhelming numbers. It wasn't elegant, it wasn't beautiful, it was effective. The Germans were about to learn the difference between those concepts. September 27, 1942. Richmond Shipyard, Number 2, 0630 hours. Temperature, 56 degrees Fahrenheit. The fog off the bay tasted like rust and diesel. Henry Kaiser stood on a platform overlooking Way 8, watching something that shouldn't be possible. Below him, 4,500 workers moved with choreographed precision. Cranes swung prefabricated hull sections, entire walls of the ship, complete with portholes, piping, and electrical conduits already installed. These sections weighed 40 tons each. They'd been assembled in fabrication sheds a quarter-mile away by workers who never saw the actual ship. "Lego blocks," Kaiser murmured. "We're building ships out of Lego blocks." The keel had been laid 4 days ago. Already the ship had a recognizable shape. In a traditional shipyard, they'd still be checking measurements and cutting steel. Otto Merrill, Kaiser's production manager, checked his stopwatch. "If the engine arrives on schedule, we'll launch in 27 days. "Make it 24. "Henry, that's 24 days. Find 3 days somewhere. The boys in the Atlantic don't have 27 days. This was the hidden advantage the Germans never calculated. Prefabrication on an industrial scale. Traditional shipbuilding happened sequentially. Install the frame, then add the plates, then add the piping, then add the wiring. Each step waited for the previous step to complete. Kaiser's innovation was to do everything simultaneously in parallel production streams, then assemble the finished sections like puzzle pieces. The hull sections were built in covered sheds by welding crews who specialized in flat plate construction. Easier, faster, more consistent than hull welding. The engine was installed as a complete unit, tested and assembled before it ever reached the ship. The superstructure, the bridge, the deck houses, was fabricated as intact buildings and lifted onto the hull by crane. "It's not shipbuilding," complained a veteran foreman from Newport News who'd come west looking for work. "It's ship assembly." Sadie, exactly. In the fabrication sheds, the rhythm was industrial music, the crack hiss of welding torches, the pneumatic thunder of rivet guns, the metallic screech of steel plate against steel plate. 200 women in welding masks worked in Shed 14 alone, joining plates that would become the starboard hull. They didn't think about the ship. They thought about their welds, their quotas, their bonuses. A woman named Wendy the welder, real name Veronica Polk, former bank teller, could complete 72 feet of seam in an 8-hour shift. Before the war, she'd typed letters. Now she joined steel with 6,000-degree arcs of electricity, and she was exceptional at it. "I pretend each weld is my ex-husband's face," she told a reporter. "Really helps with the focus." The prefabrication system meant that by the time sections reached the ship, they were 80% complete. Installation was measured in hours, not weeks. A hull section that would take 3 weeks to build in place could be fabricated in a shed in 5 days, then installed in 4 hours. The numbers were staggering. Each Liberty ship required 250,000 individual parts, 30 miles of pipe, 50 miles of wiring, 700 valves, 43 watertight doors, 600 portholes and windows. Kaiser's system built these components in factories that looked like automobile plants, not shipyards. The valves came from a facility in Emeryville that made 3,000 units per week. The portholes came from a plant in Sacramento. The piping was cut to exact lengths in Oakland, threaded and fitted before it ever saw a ship. By October 1942, Kaiser had reduced ship construction to 42 days average. The Maritime Commission was delighted. The Navy was impressed. The Germans, reading intelligence reports, adjusted their calculations. More ships, yes, but still manageable. The U-boats were sinking cargo faster than Kaiser did something that redefined possible. September 27, 1942. The same day he watched WWII. He gathered his yard managers. "We're going to build a ship in under a week." The room went silent. "That's insane," someone said. "That's impossible," someone else added. "That's the point," Kaiser replied. "I want the world to see what American industry can do when it stops being polite. We're going to build a Liberty ship in 7 days, launch it with the president watching, and show Hitler exactly what he's up against." The vessel chosen was SS Robert E. Peary, named after the Arctic explorer. The event was planned for November. The entire Richmond No. 2 yard would focus on this single ship. Every lesson learned, every technique perfected, every shortcut discovered, all applied to one vessel in a concentrated demonstration of industrial power. October and November became a trial run in controlled chaos. Crews rehearsed. Prefabrication sheds worked double shifts. The engine, a massive 2,500 horsepower triple expansion steam plant weighing 140 tons, was assembled and tested in Portland, then shipped by rail to Richmond, ready to drop into place. The hull sections were built with precision that approached obsession. Every weld X-rayed, every joint tested. This ship, the showpiece, would be built faster than anyone thought possible and built well enough to satisfy the harshest critics. November 8, 1942, 0800 hours, WWII, Richmond Shipyard No. 2. The keel of SS Robert E. Peary touched the blocks. Photographers captured the moment. Newsreel cameras rolled. What happened next was industrial warfare. Hour 1, 12. Keel laid, bottom hull sections positioned, welding crews swarming. Hour 13, 24. Side hull sections erected, internal framing installed. Hour 25. 48. Upper hull completed, deck laid, superstructure foundations set. Hour 49, 72. Engine lowered into place. A crane operation that normally took 6 hours completed in 97 minutes. Superstructure lifted onto the deck. Masts stepped. The work never stopped. 3 shifts, 8 hours each, overlapping at shift changes to maintain momentum. Searchlights turned night into day. The welding arcs were visible from San Francisco, 15 miles away, a constellation of blue-white stars burning on the Richmond waterfront. Hour 73, 96. Interior fittings, piping connections, electrical systems, cargo hold equipment, anchor windlass, lifeboats. Hour 97, 120. Painting, testing, provisioning. The engine fired for the first time at hour 104. The sound, a rhythmic thundering whoosh, echoed across the bay. Black smoke from the stack. She was alive. Hour 121, 144. Final inspections, minor repairs, loading coal, water, supplies. November 12, 1942. 1,600 hours, 6 days, 14 hours, 29 minutes after the keel touched the blocks. SS Robert E. Peary slid down the ways into San Francisco Bay, a complete, functional, certified, seaworthy vessel. 10,000 workers and spectators cheered. Bands played. Newsreel cameras captured everything. Henry Kaiser stood on the platform, cigar in his teeth, watching his impossible ship float. 4 days, 15 hours, 29 seconds. That was the actual construction time. The rest was testing and ceremony. The world noticed. The newspapers called it a miracle. The Maritime Commission called it proof of concept. The Germans called it propaganda. "It's a stunt," Wilhelm Schuler said when the reports reached Berlin. One ship, built under ideal conditions, with every resource concentrated. They cannot sustain this pace. He was right. They couldn't sustain that specific pace. They did better. By December 1942, Kaiser's 6 yards were launching ships on a rhythm that made the Robert E. Peary look slow. Richmond Yard 1 launched a ship. 3 days later, Richmond Yard 2 launched a ship. 4 days after that, Portland Yard 1. Then, Portland Yard 2. The cycle repeated, overlapping, cascading. Each yard had 6 ways. Each way held a ship. When a ship launched, a new keel was laid within hours. The yards became ship factories, operating 24 hours a day, 365 days a year. Christmas Day, 1942, 2 ships launched. New Year's Day, 1943, 3 ships launched. The average construction time dropped to 39 days, then 33, then 30. 1 ship every 24 hours from all yards combined. The Germans, tracking the numbers, began to realize their mathematics had been wrong. Not slightly wrong, catastrophically wrong. January 1943. Admiral Donitz requested updated production estimates from intelligence services. The report was stark. American Liberty ship production now exceeds 140 vessels per month. Current U-boat kill rate, 96 vessels per month. The Americans are adding tonnage faster than we can sink it. The equation has reversed. Schuler read the numbers 3 times, checked the sources, requested verification. It was all accurate. "How?" he asked. "How is this possible?" The answer was in the details his original calculations had never considered. The Americans hadn't trained 100,000 craftsmen. They'd created 100,000 specialized workers, each performing simple, repetitive tasks at incredible speed. They hadn't built sophisticated shipyards with traditional infrastructure. They'd built ship factories using automobile production techniques. So, they'd industrialized maritime construction. And in doing so, they'd made every assumption based on traditional shipbuilding obsolete. But the true scope of the catastrophe was still revealing itself. Because while Kaiser was building cargo ships, other American yards, using the same mass production principles, were building destroyers, destroyer escorts, landing craft, tankers. The entire American shipbuilding industry had adopted Kaiser's methods, modified them, improved them. By spring 1943, the United States was launching more ships every month than the entire British Empire had built in all of 1939. The Liberty ships themselves, those crude, inadequate vessels the experts had dismissed, were performing beyond every expectation. They crossed the Atlantic through U-boat wolf packs. They survived storms that should have torn apart their inferior welded hulls. They delivered millions of tons of cargo, food, fuel, ammunition, vehicles, to Britain, Russia, North Africa. Some broke in half, some developed cracks, some had engine problems. But the vast majority worked, and there were so many of them that losses didn't matter. The German U-boats were hunting in an ocean that was flooding with targets. For every ship sunk, 3 more appeared. The Wolfpack tactics that had been so effective in 1941 and 1942 became futile exercises against an enemy that could replace losses faster than they could inflict them. "It's like fighting the tide," a U-boat commander wrote in his diary. "We sink them, and they keep coming. Always more. How can they have so many ships?" The answer was Henry Kaiser, standing in a dusty California field in 1940, looking at the bay and asking a question no expert had considered. What if we don't know the methodology? March 19, 1943. 2200 hours. U-571, North Atlantic, 47 degree N 32 degree W. Water temperature, 39 degrees Fahrenheit. Cabin air thick with sweat, diesel, and mildew. Kapitänleutnant Gustav Lussow stared at the chart table, and the numbers refused to make sense. He'd been at sea for 38 days. His type sink U-boat had sunk 4 cargo ships, 23,000 tons total. By pre-war standards, an excellent patrol. By 1942 standards, adequate. By March 1943 standards, it was worse than nothing. Because during those same 38 days, his intelligence brief reported that the Americans had launched 19 Liberty ships, 190,000 tons of new cargo capacity. He'd sunk 23,000. The net result? The Allies had gained 167,000 tons. He was losing a war he was winning. Herr Kalayun, his executive officer, said quietly, "Convoy HS 229 spotted. 47 ships." 47. Lussow had seen convoys of 20 ships in 1941 and thought them massive. Now they sailed in formations that stretched across 5 miles of ocean. 3 dozen cargo vessels surrounded by destroyers and corvettes like cattle protected by armed dogs. Any stragglers? 9, tight formation, air cover from escort carrier. Escort carriers, another American improvisation. They'd taken cargo ship hulls, Liberty ship hulls, added a flight deck, and created cheap, mass-produced aircraft carriers for convoy protection. Crude, barely functional, effective. Lussow had been hunting convoys for 3 years. He'd developed instincts for the patterns, the vulnerabilities. But the patterns were changing. The convoys were better protected. The air cover was constant. The escorts had better radar, better sonar, better tactics. And most damning of all, it didn't matter. "Even if we sink 5 ships from that convoy," he said aloud, "the Americans will replace them in a week." His executive officer said nothing. What was there to say? The mathematics that Wilhelm Schuller had presented so confidently in December 1941 had become an inversion, a nightmare equation where every variable pointed toward inevitable defeat. U-boat production, 22 boats per month. U-boat losses, 18 boats per month. Net gain, 4 boats per month. American ship production, 140 Liberty ships per month, plus destroyers, escort carriers, tankers, landing craft. American ship losses, dropping to 60, 70 vessels per month as convoy tactics and air cover improved. Net gain, 70-plus ships per month. The curved lines crossed in late 1942. By March 1943, they were diverging toward mathematical impossibility. The Allies were adding cargo capacity 6 times faster than the U-boats could sink it. Lussow had read the internal memos from BDU, U-boat Command. The tone was changing from confident to desperate. Admiral Donitz still spoke of strategic pressure and tonnage war, but the truth was visible in the operations maps. The Atlantic was becoming an American lake, flooded with ships. Back in Berlin, Wilhelm Schuler was experiencing his own mathematical breakdown. April 2nd, 1943, 14:30 hours. His office in the Reich Ministry. Rain against the windows. The production reports covered his desk. Verification after verification. Every source confirmed the same impossible numbers. The Americans had built 597 Liberty ships since Pearl Harbor. 15 months. 597 ships. His 1941 estimate: they might build 80 ships in that time frame. The error wasn't a miscalculation. It was a fundamental misunderstanding of what was possible. Schuler had designed the Bismarck, a masterpiece of naval architecture, 50,000 tons of displacement, advanced fire control, Krupp cemented armor. That single vessel represented the pinnacle of German engineering, built over 3 years by Germany's finest craftsmen. The Americans had built 597 ships in the time it took Germany to build 47 U-boats. But they're inferior vessels, he told himself, repeating the mantra that let him sleep. Crude, simple. They'll break. They'll fail. Quality will defeat quantity. Except they weren't failing. The reports from U-boat commanders were consistent. The Liberty ships were tough. Their welded hulls flexed in ways riveted hulls didn't. Their simple engines were easy to repair. Their unsophisticated design meant damage that would cripple a complex vessel could be patched with makeshift repairs. One Liberty ship, SS Richard Hovey, had been torpedoed in the mid-Atlantic. The explosion blew a 30-foot hole in her side. She should have sunk. Instead, her crew plugged the hole with mattresses, timber, and concrete, maintained steam, and limped to port at 6 knots. She was repaired and back in service within 2 weeks. A British freighter with a similar hit would have gone down. The Liberty ships were succeeding because of their crudeness, not despite it. Schuler drafted a memo to the High Command. He tried to frame it in strategic terms, not as an admission of error, but as an observation requiring policy adjustment. The words fought him. How do you explain that your expert analysis was wrong, not in degree, but in fundamental assumptions? The American industrial capacity has exceeded projections, he wrote, then deleted it. Too weak. Enemy ship production has reached levels requiring recalculation of Atlantic strategy. Better? Still inadequate. He settled on, current American production rates indicate mathematical impossibility of achieving strategic victory through tonnage warfare. Alternative approaches required. It was professional language for, we lost. We didn't know we could lose this way, but we did. The memo went through channels, reached Admiral Donitz, was discussed at the highest levels. The official response: continue current operations, increase U-boat production, develop new technologies. Translation: we have no alternative. Fight on and hope something changes. But the men in the submarines knew. The men watching convoys sail past, untouchable behind screens of escorts, knew. The men reading reports of American production numbers knew. May 1943. Black May, the U-boat crews called it. 43 U-boats lost in 1 month. The highest casualty rate of the war. The Wolfpack tactics that had been so effective were failing against improved Allied defenses and overwhelming numbers of escorts. The Battle of the Atlantic, the Battle of Mathematics, was over. The Allies had won it with industrial production, not naval combat. And at the center of that victory was a 48-year-old dam builder who'd never built a ship before Pearl Harbor. June 1943. Richmond Shipyard, No. 2. Henry Kaiser walked through the yards at sunset, watching the shifts change. 5,000 workers streaming out. 5,000 streaming in. The night shift. The work never stopped. WWII 4 was launching a ship. WWII 7 had a hull taking shape. WWII 2 was laying a keel. "How many have we built?" he asked Otto Merrill. "From all our yards? 912. "How many will we build?" Merrill checked his projections. "At current rates, we'll hit 1,500 by this time next year. Total program calls for 2,700 Liberty ships." Kaiser nodded, lit a cigar, watched the welders' arcs dance in the gathering darkness. Somewhere in the Atlantic, those ships were keeping Britain alive, feeding the armies in North Africa, supplying the Russians, building the material foundation for D-Day. And somewhere in Germany, engineers and admirals were staring at production reports, trying to understand how they'd been so completely, so catastrophically wrong. The answer was simple. They had calculated what shipbuilders could do. Kaiser had shown what American industry could do. The difference was everything. August 14th, 1943. Liverpool Docks, England. 0640 hours. Morning fog. Temperature 52 degrees Fahrenheit. The air tasted of salt and coal smoke. Dock Supervisor Arthur Pemberton stood on Pier 7, counting ships, and couldn't quite believe his eyes. 17 cargo vessels were queued for unloading. 17. Every berth was full. Ships were anchored in the Mersey, waiting for dock space. American ships. Liberty ships. Simple, ugly, beautiful ships carrying food, fuel, ammunition, locomotives, trucks, aircraft, everything Britain needed to survive and fight. 3 years ago, Pemberton told his assistant, we were rationing bread because we couldn't get enough cargo through. Now, we're rationing dock space because we have too many ships. The transformation had been absolute. In 1942, Britain was starving. Fuel stocks were at critical levels. The U-boats were winning. By mid-1943, the docks were overwhelmed with cargo. The problem wasn't supply, it was unloading capacity. Liberty ship. SS John Carver was disgorging 10,000 tons of wheat. SS William Clark carried trucks and jeeps. SS Thomas Jefferson, aviation fuel in drums. SS Benjamin Franklin, artillery shells. On and on, ship after ship, each one representing a 30-day build time in an American yard. "They're not even good ships," Pemberton muttered, watching longshoremen work. "Engines break, steering's temperamental. But bloody hell, there's so many of them." That was the genius of Kaiser's system, and the thing the Germans had never understood. Adequacy in overwhelming numbers beats perfection in scarcity. A perfect ship that doesn't exist can't carry cargo. A crude ship that arrives every day can win a war. The numbers told the story with brutal clarity. 1941, 1,299 Allied ships sunk, 800,000 tons of new construction. 1942, 1,664 Allied ships sunk, 7 million tons of new construction. 1943, 597 Allied ships sunk, 14 million tons of new construction. The curve had reversed. By late 1943, the Allies were adding ships faster than they could train crews to sail them. The bottleneck wasn't production, it was personnel. "We need more sailors," the Maritime Commission reported. "We're building ships faster than we can man them." America trained sailors, pulled men from farms, cities, factories, gave them 8 weeks of instruction, and put them on Liberty ships. Many had never seen the ocean. They learned seamanship by doing it, crossing the Atlantic with German submarines hunting them. Most survived, some didn't, but the ships kept coming. September 1943. Murmansk, Soviet Union. The northern convoy route, temperature 28 degrees Fahrenheit. Ice forming on the railings. Soviet dock officer Dmitry Volkov watched Liberty ship SS Christopher Newport unload heavy trucks. American-made GMC 6x6S, destined for the Red Army. Behind her, 6 more American cargo ships waited their turn. "The Americans have strange priorities," Volkov said. "These ships are slow, weakly armed, but they bring everything we need." The Lend-Lease program was flooding the Soviet Union with material. Tanks, aircraft, trucks, food, fuel, medical supplies. Half of it arrived on Liberty ships that had crossed the North Atlantic through the worst seas on Earth, dodged U-boats, survived German air attacks from Norway, and delivered their cargo to the Arctic ports. "How many ships do the Americans have?" Volkov asked the interpreter. "The latest report says they're building 140 per month." Volkov was quiet for a moment. Then, "We are allies with a nation that builds 140 ships per month. Germany picked the wrong enemy." The strategic implications were cascading beyond the Atlantic. Liberty ships were being deployed to the Pacific, to the Mediterranean, to the Indian Ocean. They were being converted into hospital ships, repair ships, aircraft transports. The basic hull design was being modified into a dozen variants. Some Liberty ships became Empire ships, built in America but operated by Britain under different names. Some were transferred to the Soviet Union. Some served in the U.S. Navy as cargo vessels and ammunition ships. They were everywhere. October 1943. Somewhere in the North Atlantic, U-234 surfaced to charge batteries. Captain Lieutenant Werner Richter scanned the horizon through his binoculars and saw nothing but empty ocean. "Convoy must have passed," his executive officer said. "Or avoiding us," Richter replied. "They have radar. They route around known U-boat positions. We're hunting ghosts." The tactical situation had collapsed. Allied convoy routing now used intelligence from decoded German communications, shore-based direction finding, and long-range aircraft patrols to steer convoys around U-boat concentrations. And when convoys did encounter submarines, they had enough escorts to fight through without significant losses. The hunter had become the hunted. "How many ships did we sink last month?" Richter asked. "Our boat, 1, damaged another." "And how many did the Americans build?" Silence. 140, Richter said quietly. "They built 140 ships. We sank 1. This is mathematics. And the mathematics says we've lost." Back in Berlin, the memo traffic was increasingly desperate. Proposals for new U-boat types with better performance, plans for submarine-launched guided missiles, ideas for underwater supply chains, strategies for concentrated attacks on major ports. None of it addressed the fundamental problem. American industrial output had reached levels that made conventional warfare obsolete. You couldn't sink ships faster than America could build them. You couldn't destroy tanks faster than Detroit could produce them. You couldn't shoot down aircraft faster than Boeing, Lockheed, and Douglas could deliver them. Wilhelm Schuler had stopped attending strategy meetings. His expertise, traditional naval architecture and shipbuilding, had been made irrelevant by Henry Kaiser's revolution. There was nothing left to calculate. The variables had changed beyond recognition. November 1943. Kaiser's Portland Yard launched its 500th Liberty ship. The celebration was muted. The workers had become so proficient that ship launches were routine. Exciting at first. Normal by the 500th. "We've improved the design," Clay Bedford reported to Kaiser. Better welding techniques, reinforced stress points, improved engine reliability. The new vessels are 15% more durable than the original specification. Kaiser nodded. And the build time? 27 days average. Some yards are hitting 24 consistently. Less than 1 month from keel to water. For a 10,000-ton cargo ship. The Germans had estimated 240 days. The Americans were doing it in less than 30. How many total? Kaiser asked. All American yards, all ship types. We're approaching 8,000 vessels since Pearl Harbor. Cargo ships, tankers, destroyers, escort carriers, landing craft, everything. Kaiser looked out over the yard. 3 ships were under construction in visible range. Cranes moving. Welders working. The constant rhythm of industrial production. The Germans thought we couldn't do it, he said. They calculated our capacity and determined it was impossible. They were right, Bedford replied. By traditional shipbuilding standards, it was impossible. Then we built ships wrong. Bedford smiled. We built them American. December 1943. The strategic balance had shifted so completely that Allied planners were no longer worried about supply lines. They were worried about storage space. Britain's warehouses were overflowing with American material. Fuel tanks were at capacity. Ammunition depots were full. The problem wasn't getting cargo to Britain. It was finding places to put it all. This abundance, this overwhelming material superiority, was creating the foundation for Operation Overlord, D-Day, the invasion of France. It required stockpiling millions of tons of supplies in Britain: fuel, ammunition, vehicles, food, medical supplies, construction materials. The Liberty ships were delivering that mountain of material, one 10,000-ton cargo load at a time. By June 1944, they would deliver 5 million tons of cargo to British ports in the 6 months preceding the invasion. One merchant seaman, interviewed years later, described it simply: "We weren't warriors. We were teamsters driving big rigs across a dangerous highway. But we delivered the goods. And that's what mattered." By early 1944, the Liberty ship program had achieved its purpose so completely that the Maritime Commission began reducing production. Not because of failure, because of success. They had more ships than they needed. Final production numbers: 2,710 Liberty ships built between 1941 and 1945. Average construction time, 42 days. Fastest construction, SS Robert E. Peary, 4 days 15.5 hours. Total cargo delivered, over 70 million tons. Ships lost to enemy action, 200. Replacement rate, 1 ship sunk, 13 built. The German U-boat force, which had come so close to victory in 1942, spent the last 2 years of the war being systematically destroyed. Hunted by aircraft, depth-charged by destroyers, tracked by radar, decoded by intelligence services, and overwhelmed by the sheer volume of ships that made tonnage warfare mathematically impossible. Wilhelm Schuler survived the war. He was never prosecuted for war crimes. He designed ships, not concentration camps. But his reputation as a naval expert was shattered. His calculations had been presented as authoritative, and they'd been catastrophically wrong. He worked as a maritime consultant in Hamburg after the war, a quiet man who designed small coastal freighters and avoided discussing the conflict. He died in 1958, and his obituary mentioned his work on the Bismarck, but not his 1941 analysis of American production capacity. Some errors are too fundamental to memorialize. September 2nd, 1945, Tokyo Bay, aboard USS Missouri. Temperature, 74 degrees Fahrenheit, clear skies. The surrender ceremony was formal, precise, theatrical. Generals and admirals signed documents. Photographers captured the moment. The Second World War officially ended. But the war had really ended 3 years earlier, in the shipyards of Richmond and Portland and Baltimore, when American industry demonstrated that it could produce cargo ships faster than enemies could sink them. Everything else, the battles, the strategies, the tactics, was implementation of that fundamental advantage. Henry Kaiser stood in his Richmond office 2 weeks after the surrender, looking at photographs of ships. His ships, 1,490 vessels from his yards alone, more than 30% of the entire Liberty ship program. "What are you going to do with them?" someone asked. "Sell them," Kaiser replied. "The government doesn't need 2,700 cargo ships in peacetime. Shipping companies will buy them cheap." And they did. Liberty ships became the backbone of post-war global trade. Renamed, reflagged, sent to every corner of the world, they hauled grain from Argentina, carried timber from Scandinavia, transported manufactured goods from Japan's rebuilding industries. Some Liberty ships served for 30 years, far beyond their designed lifespan. The crude, temporary vessels outlasted many traditional ships built with pre-war craftsmanship. The SS John W. Brown and SS Jeremiah O'Brien survive today as museum ships, still operational, still seaworthy. You can visit them, touch the welds that experts said were inadequate. Stand in the engine room where 2,500 horsepower of 1879 technology still functions. But the real legacy wasn't the ships themselves. It was the philosophy they represented. Kaiser had proven that adequacy at scale beats perfection in scarcity. That speed of production matters more than elegance of design. The trained specialists are optional if you can break complex tasks into simple, teachable steps. These principles became the foundation of post-war American manufacturing. The aerospace industry adopted them. The automobile industry refined them. The computer industry perfected them. The Liberty ship wasn't just a vessel. It was a prototype for mass production applied to complex systems. "How did we beat the Germans?" one of Kaiser's welders asked at a 1950 reunion. Someone answered, "They built beautiful ships slowly. We built adequate ships fast. They ran out of time before we ran out of ships." That reduction, elegant but crude, captured the essential truth. The Germans lost the Battle of the Atlantic not to superior Allied naval tactics, not to code-breaking, though that helped, not to technological innovation. They lost to manufacturing capacity, to industrial logistics, to the ability of American factories to produce faster than German weapons could destroy. It was a new kind of warfare, and Germany had prepared for the wrong war. Wilhelm Schuller's 1941 calculations were correct for the war he understood: a war of traditional shipbuilding, craft production, limited capacity. He couldn't imagine a war where ships were products, where maritime construction used automobile assembly techniques, where adequacy trumped perfection. His failure wasn't stupidity. It was expertise. He knew too much about how ships should be built to imagine how ships could be built. Henry Kaiser's advantage was ignorance. He didn't know the rules, so he didn't know which rules could be broken. The lesson extends beyond shipbuilding, beyond World War II, beyond manufacturing. Experts optimize within known constraints. Disruptors change the constraints. Expertise answers the question, how do we do this better? Innovation answers the question, why do we do it this way? Kaiser asked the second question. The Germans never did. Today, Liberty ship production is studied in business schools as a case study in rapid scaling, in engineering schools as an example of design for manufacturability, in military academies as a lesson in industrial warfare. But the human element gets lost in the analysis. The housewives who became welders, the farmers who became fitters, the teenagers who built ships while their brothers fought wars. They didn't think they were revolutionizing warfare or manufacturing. They thought they were doing a job, earning a paycheck, helping the war effort. Veronica. Wendy the welder Polk went back to banking after the war. She never welded again, but she kept a photograph of the first Liberty ship she'd worked on, SS Ocean Liberty, and when her grandchildren asked what she did during the war, she'd show them the picture and say, "I helped build that." 60 years later, one of those grandchildren became a software engineer. She describes her approach to product development as ship it fast, iterate, improve. The Liberty ship philosophy applied to code. She doesn't know that's where it came from. The ideas have become so embedded in American business culture that their origin is invisible. Farce. That's the true legacy, not the ships, the mindset. The belief that constraints are negotiable, that expertise can be learned quickly, that complex problems can be broken into simple tasks, that speed and volume can overcome perfection and precision. These ideas, tested in the shipyards of 1942, proven in the Atlantic from 1943 to 1945, became the operating system of American innovation for the next 80 years. And it started because a dam builder looked at the ocean and said, "I can build ships faster than the experts think possible." He was right. The experts were wrong. And 2,710 Liberty ships proved it. Epilogue. The number that changed history. December 7th, 1941. Pearl Harbor burns. America enters the war. December 7th, 1945. 4 years later, the Allies have won. The difference? 2,710 Liberty ships. 41 million tons of cargo delivered. 5,000 trips across the Atlantic. One ship launched every single day for 3 years straight. The Germans calculated it was impossible. They were experts. They were certain. They were catastrophically wrong. Because they measured what America had done, Kaiser measured what America could do. That difference between the past and the possible won the war. Remember this, the next time an expert tells you something can't be done. They might be right about what they know. They're probably wrong about what they don't. Henry Kaiser didn't know you couldn't build ships that fast, so he built them anyway. Sometimes ignorance is the most powerful tool in the box. Sometimes the best way to solve an impossible problem is to not know it's impossible. Sometimes, just sometimes, the person who changes everything is the one who never learned the rules in the first place. The Germans learned that lesson in the North Atlantic, watching Liberty ships flood across the horizon like an industrial tsunami. By then, it was too late to matter. The math had already changed. The war was already over. They just didn't know it yet. But Henry Kaiser did, standing in his Richmond shipyard, watching another hull slide into the water. He knew. And he smiled.